Hello, my name is Ives Danoskis and I'm the product manager here in SAF Tehnika for the Spectrum Compact product line. In today's webinar, we will take a look at the Spectrum Compact V-band and E-band spectrum analyzers and applications of these devices. Two Spectrum Compact V-band and E-band spectrum analyzers cover the frequency range from 56 to 87 GHz. One of the key differences of these units when compared to the other Spectrum Compact models is that they don't have the coaxial RF input, but instead waveguide. This means that those Spectrum Compacts have to be connected directly to the antenna or waveguide to perform RF measurements. Just like all the rest of the Spectrum Compact family units, they are designed for field applications and has well-known characteristics of the series. Battery-powered standalone device with an easy-to-use graphic user interface. Additionally to the Spectrum Compact V-band and E-band units, we also have various accessories suited for field applications. Horn and parabolic antennas, waveguide attenuators and mountings to fix the Spectrum Compact with the antenna into the stable position. One of the most common applications in the field is to verify the microwave radio parameters. In the case of the Spectrum Compact V-band and E-band, you will need to place the device either into the main beam of the antenna of transmitter for which the measurement is taken, or very close to the transmitter. This picture shows how such verifications was carried out during one of our trainings with the customers. You can see the Spectrum Compact E-band facing the back of the transmitter and still receiving a signal to perform the verification. This way it is possible to verify if the transmitter is operational, as well as to verify its center frequency and bandwidth using the power in band function. Another popular application is the microwave point-to-point link antenna alignment and troubleshooting. The high sensitivity of Spectrum Compact E-band allows signal detection very early in the antenna alignment stage, which allows to continue with fine alignment. This significantly decreases the time spent on the tower for link installations and allows troubleshooting for any issues with the link. Verify RF spectrum occupancy in the code channels and absence of interference, which could affect the link performance. Spectrum Compact E-band RF interface is compatible with standard UG387 flange, which allows connection with various antennas, waveguides, and radios. The case study with Italian mobile operator Wintry dives deeper how they use Spectrum Compact E-band for troubleshooting and fixing the E-band link failure, which led to the network downtime and impacted their service level agreement. They started troubleshooting with comparing the measurements of signals from the far and the near terminals. This allowed to determine that link failure occurred due to the damaged point-to-point antenna on the near terminal. Wintry engineers installed a new point-to-point antenna and used Spectrum Compact E-band to realign the new antenna in less than 15 minutes. Once done, the link performance was restored. And now let's hear from the Wintry how they carried out this task.
Describe how the Spectrum Compact E-band was used to troubleshoot the E-band backhaul link.
And in this case, it's not so easy to find where is the problem, in which side of the link there is the problem. The test is quite easily. If you receive it on the craft terminal, for example, minus 65 level dBm, and on the spectrum analyzer the level is quite the same with the our antennas, the result is that in this side of the link the antenna of the radio link is not working, and so you have identified what is the side where there is the problem. And in this case we are lucky, and because it's not necessary to climb, there is the line of shaft directly on the ground. But believe me, it's very useful to understand where is the antenna or the coupler of the antennas of the radio link where is the fault. Spectrum analyzer, you can check exactly when the path is correct, the alignment is perfect. Instead, with the multimeter, this is not possible.
Describe other typical issues for which you would use Spectrum Compact E-band to troubleshoot.
For example, we have some case of the radio links is near to the sea or to the lake, and in this case, in some months of the year, for example in May, the evaporation of the water create one distortion of the path. You don't know if have seen this before, and the radio links goes up and down without any alarm. You don't. It's not too easy to understand what's happening. But with this spectrum analyzer, you can check the spectrum figure, and it's possible to see a distortion of the spectrum figure, and so you can identify this fading problem created by the water, by the sea or the lake. We have some cases. For solve this problem, it's necessary to modify the alignment of the azimuth of the antenna, and with this with the instrument we have lost some dB, but we have solved this problem. This is happening only when the station of the radio link is at the same level of the water. We use this system also for lower frequency. We have over equipment with horn antennas and now we are able to identify exactly where is the antenna of radio link that don't work, and you have cut down the half of the work that you have to do, because you have identified exactly where is the side of where is the problem. We have used this system not only for the event but also for the lower frequency. It's very fast. I know the cost of the instrument it's quite expensive, but the time that you save it's too much. It's much. You more to use it and you find new application, new way to solve problem.
Which features of the Spectrum Compact E-band helps RF troubleshooting?
I think that the most important things is the small dimension of the instrument, and this is very important when you go up to the tower. You can put the instrument directly on the antenna, so you don't have guides or things like this. The life of battery is good. We don't have problem without the life of the battery, and is very, very rugged. The case is not the plastic, but from my point of view is very taut, and so this is never good things when you go to the tower. The best feature of the instrument is to check exactly the path radio directly in the spectrum, and this is, believe me, can help very, very much in the alignment.
The growing use of advanced driver assistance systems, or in short ADAS, in automotive industry drives the requirement to perform RF tests of the radars used by the ADAS. The Spectrum Compact fits the need for radar parameter verification in the field, for which we will have a short demonstration. So today we will look at how to use the Spectrum Compact E-band to verify basic RF parameters of the automotive radar. With Spectrum Compact E-band, it's possible to do a quick verification if the automotive radar is transmitting. Here we see the signal from the radar in the spectrum. This means that the radar is transmitting. I can place my hand in front of the antenna, which then blocks the signal from the radar. Here you can see that the signal disappears in the spectrum, and if I take my hand off the antenna, then it reappears again. By using the max hold function, we can gather a highest power levels over multiple sweeps, which then allows to verify the bandwidth in which the radar is working. So here we can see that the bandwidth is at 850 megahertz, and the center frequency is at 76.5 gigahertz, which is what we expected to see. Further, we can use the max hold trace also to evaluate the envelope of the radar signal, which allows us to understand if there are any deviations from the expected signal shape. By changing the position of the Spectrum Compact analyzer towards radar, we can observe the signal level changes. The strongest signal is while facing the radar directly, but as we move to either side of the vehicle, the signal level decreases. So now I saved the measurement data to post-process it in the Spectrum Manager PC software.
And we're back in the studio. For the last part of the webinar, we will show how the Spectrum Compact can be used not only as the field device, but also when it is being controlled remotely. In this setup here, I have the Spectrum Compact E-band unit, which is connected to the PC, and here we have a SAF Tehnika Integra E-band radio, and what we will do is that I will send the API commands to the Spectrum Compact to set the measurement parameters, and the Spectrum Compact will reply with measurement results in the form of a data string. So for demonstration purposes, we will use the PuTTY terminal to connect to the Spectrum Compact E-band unit. And this then allows us to send commands to the Spectrum Compact, and we can change start and stop frequencies, trace. So this data string then can be used for integrating it into the other softwares to do the signal processing, the data processing, and store it and visualize it, this data, however the user desires to do. The API commands allow Spectrum Compact to be integrated with third-party systems that are being used for quality assurance or automated testing. This then concludes our today's webinar, where we looked at the applications of the Spectrum Compact V-band and E-band for the microwave point-to-point networks and automotive radars. Hope you enjoyed it. Thank you and see you next time.